Hi, thank you for choosing this video to watch. Today I'm going to talk about my stereo. So, fair warning, it's a video about a guy talking about his stereo. But it's a project that I've been thinking about for a long time, since I moved into this space. And it's basically that I acquired this amplifier that's basically specifically made for home theater. Basically just so you could plug a DVD player and a TV into it and get a certain kind of sound. But I also have had this old amplifier for my tape deck and my CD player and turntable when I had one. And I wanted to have all of the signals coming out of my speakers. And I thought it would be as simple as just sticking the speaker wires in to both of them. But apparently that does not work for various reasons. Mostly because if you try to send a signal out of one amplifier into a speaker and you've also connected this amplifier into the speaker, you'll be sending the signal into the other amplifier and you'll fry something. Even if you have it turned off, there's impedance problems with having a big load on, you're basically having two loads. One is a speaker and the other one is the other amplifier. So, it's not possible. So, I've been thinking about it as, when the commercial comes on TV, I think, how can I get these two to get together? And I thought of a switch. And I've pictured it in my mind, and I've drawn a diagram of it, and I'll show that to you. And I want to create that. So, that's what this video is about. And I will show that to you. Let me draw you a picture. So, this represents the amplifier for the television. This represents the amplifier for the stereo. And these are the two speakers, the right and the left. And every speaker has a plus and a minus. So, normally, let's say the TV one would run plus and minus right up to the right speaker, and left up to the left. What I want to do is put a box in between them so that the stereo has its own little posts and the TV has its own little posts. And I'll put a switch in between them so that when I go like this, only the stereo ones turn on, go to the speakers. And when I go like this, only the TV ones go to the speakers. Right? So here I drew myself a little picture of the box. And then I have some, this is me working out some ideas about how it works out. I guess this would be a conceptual diagram. Here's another one. Just trying to figure out how the bus would work, and then how I would construct a box. And down here I have a mistake. And this is, I think, the idea that I like the best. It's the sort of an X-ray diagram of what it would look like for these two, the slider and the circuit board, to fit together. So on one side would be the TV posts, plus and minus for left and right, and on the other side the stereo, and they'll have a little spring that rubs up against a circuit board that I will make, and then when I slide it with the slider, it'll move sort of like this. So the little springs would be resting on, let's say, the TV ones, the TV pads first, and they'll be resting on the spaces between the stereo pads. And then when I slide it over, then they'll be resting on the pads for the stereo, and they'll be resting on in between the pads for the TV. That's the idea. Oh yeah, here's a little picture of what it would look, of what the board would look like. The circuit board would be very simple, just 12 copper pads and a little trace that goes to the posts, to the terminal blocks. So I have, actually, let me see if I can show you, I have some terminal blocks here that I plan to stick in there. So this little post here will go right into the circuit board, and a trace will lead to a pad, And then here's where I would unscrew this little screw, and in between the screw kind of sandwiches two pieces of metal that I can fit the circuit. Let's see if I have one here. Yeah, I do. So take the, oh, that's not right, like this. So take a little stereo wire and stick it right in there. So I did buy some circuit boards here. These are blank circuit boards, and they come all the way from the other continent, on the other side of that ocean over there. And on one side it's fiberglass, and on the other side it's beautiful layer of copper. And if you see here, can you focus? This layer of copper is very, very slim. So I will be taking some of this. I just got some of this ferric chloride, and I'll be using that to etch away all the copper except for a little pad. And that's what I'll be using. I'm going to cut this on my saw. So let's move on. Now, during the design process, I decided I wanted to get a 2-gang terminal block. So this is just to show you, when you're buying these things, make sure you pay attention to the pitch. That's the distance between the posts, from the center of one post to the center of the other one. And for this one, it's 9.5 millimeters. And that's what I used when I was designing these little pads on Photoshop. And this is a demonstration of where the posts would go. I decided not to put those holes there. You'll notice that I've changed the configuration a little bit since I've started doodling, and that's just because I wanted a little more space between those little copper tines I was talking about, so that if you're looking at it on the computer screen, it'll be moving, the switch will be moving up or down instead of laterally. So I'll have the speakers on the bottom playing as you see it on the screen, and the TV will be in the middle, and the stereo will be in the top, all connected by one bus. And the TV, let's say, starts out contacting with the speakers first, and then I move it up to the stereo, and the tines fall off of those pads for the TV. That's the plan. And after I printed that out on a slick piece of transfer paper, I'm going to cut it out and lay it face down onto this little sheet of copper and heat it up, and the carbon that is laid down by the printer should melt a little bit into the copper. Just enough to make it stick, to block it, so that when I put it in the ferric chloride, everything else but the stuff under the carbon will get eaten away. And so when I take some acetone and wipe it off, I should have nice clean little copper pads, and we'll see if that happens. So I just want to make sure that the iron is hot enough. You can see it's 378 degrees. That's plenty hot. And when I smash it down, I only keep it down for a few seconds. But we'll see what happens. Here's my container of ferric chloride, and I put it in the microwave for about 45 seconds just to warm it up a little bit. I think it helps with the etching, but before I put my board in, I make sure I just touch it up a little bit with a magic marker, and it seems to help. I haven't done tiny details with the magic marker, but I did want to just experiment a little bit with putting my initials here on this board, and we'll see how it works out. And then I just dunk it in there and let the ferric chloride do its work. I kind of swish it around for maybe about 15 minutes. It hasn't been the whole 15 minutes yet, but I did want to stop it in mid-etching just to show you what it looks like as the copper is starting to melt away and you can see the fiberglass underneath. But next time you see it, it'll all be gone, except the stuff that's underneath those little black patches. I just wanted to show you that you can do a little more detailed work with that process. This is a circuit board I made for a power distribution bus. You can kind of see here, if I can reflect it correctly, the plus, the neutral, and the minus, and then how it distributes up to 4 other sets of those. And also, even more tinier detail is this circuit board. It's actually a double-sided circuit board. I made it for a pulse width modulation controller for a motor and a tape player. And I think I've used that in a previous video. Maybe I'll use it in a future video, that little thing. So you can see that it's tiny details. I can get even tinier, and I did that for another project, which I'll show you next. And this is a touch plate controller I made based on Synth DIY Guy's touch plate controller project. And it's basically just 2 copper traces that wind along the surface of this. And when you put your finger on them, it completes the circuit. And here's my first attempt. You can see how much fatter the traces are. And I actually did that with a magic marker instead of a computer. So now I'll just give you a little demonstration of how this works. This next section will highlight the construction of the switch. So it starts out with drilling holes in copper to make little tiny tines. Each one of them needs to be riveted to the board, and some of them will be bent up into a post, and some of them will be fashioned into a little lever, into a little spring. So please enjoy the musical interlude while I make some copper tines.
now you're seeing the continuity test, where I'm making sure each little metal tine is connected to the correct one. So on the bottom, I want to make sure the four on the left are connected to the speaker, and the ones on the right are connected to the speaker, but they're not connected to each other. That would be a bad thing. And after I do that, I'll turn this around and set it on the pads and make sure that when I have the TV ones resting on the pads, that they're connected to the speakers. And if you've never used a multimeter before, I just want to point out that it is turned to the continuity setting. Is that little red symbol down there on the left. And if you're looking at the screen, it says OL, it means over limit. That's not what we're paying attention to. We're paying attention to the little beep you hear when I touch the black lead to one post and the red lead to another. That's making sure that I have made the connection. And here I am making some adjustments to the little leads to make sure that each lead is touching each pad. And this is where it gets a little complicated, and this phase went on for a little too long. I didn't film it all. I'm just showing here what I envisioned to be happening. And at the very end, you'll see my poor little hand resting on the table in defeat.
Well, as you see, I've tried to make a trial run on this switch, and it doesn't work. It won't work. It's too fiddly. It's too bad though. I had fun making this, and I had fun making this, but I won't have fun trying to get these to fit together. So I'm going to give up on this, put the idea aside for a future, because I have another idea already on how to make a giant DIY switch for these amplifiers. But meanwhile, I bought one of these. This is a real switch made by a real company, and it does exactly the same thing that I have been describing. This side will be for the stereo, this side will be for the TV, and this in the middle are the speakers. So I flip it this way, and the amplifier from the stereo goes to the speakers. Flip it that way, the amplifier for the TV goes to the speakers and turns off the ones from the stereo. And the gap between the two is so small, I don't think I have to worry at all about any kind of resistance or impedance or anything. So I'm going to put this in a little case and wire it up and show it to you. Well, here it is. It looks like it says no, but it actually says on. So I made a little wooden case for it. Cute, with the aluminum panel, and all the wires are stuck in there. Whoops, that wire is not stuck in there. But there they are.
So here's the proof that it works. I have two amplifiers playing music at the same time, but you're only hearing one coming from the TV. And I go over here and I flip the switch, and now you're hearing the music that's playing on my stereo amplifier, which is a little tape by Davey Music. Sounds beautiful. Then when I switch it back, you hear the video that's playing by Amber CW. That sounds beautiful too. Sounds just exactly the way it would normally. So thanks for hanging around just to watch me buy a switch and install it. I hope this was instructive.